All right, so just a little video to kind of help you out on a few of the review problems for the Unit 1 quiz. So as far as ones that I've noticed people having some trouble with, the first two lessons were focused when we did the Sapphire Island problems within the lessons and the homework problems that went with it. They're focused on your ability to read through a situation and write an equation or an inequality that goes along with that. So what we have in the first couple are some situations where you need to then interpret them to come up with an equation or an inequality. So I'm going to start actually with the first set of problems because it seems like a lot of people don't actually understand how tax is calculated. So it seems like a good place to start. So it said in the problem that Jerome is buying a sweater and it's 20% off, and it tells you how much the tax rate is, and it also wants you to calculate the original price. So if we're looking at number 7, the things that we know that it's 20% off. We know that tax is 8.25%. We know that his final price that he actually paid at the register was $25.10. So if you think back, and again, take yourself out of all of the numbers and everything that's been given to you for just a second, and think about if you're at a store buying something. When you look at the price tag and what you get when the person at the register tells you how much you owe, those are two different things. And in general, what we have is whatever's on the price tag, whether it's sale or not, whatever's on the price tag plus an amount of tax equals the final price. So hopefully we can all agree on that part. So if you look at what you've been given the final price right here. So that needs to go in this part of our equation. The other part of the equation, the price tag, well, the original price is what we don't know. So that is our variable. So X is going to be the original price. Now, the price tag and the original price aren't the same thing because it's 20% off. So we need to take the original price and take 20% off of that. The easiest way I think to do this is to say, if the price is 20% off, that means it's 80% on, meaning Jerome is actually going to pay 80% of whatever the original price is. So 80% of original equals the price tag. And again, this is all just background information that I'm organizing. So 80% in math is 0.8. Of in math means to multiply. The original is what I don't know, that's my x. Well, 0.8 times x is just 0.8x, and I think I used p when I did it, so certainly the type of variable you use doesn't matter. But that's the price tag. Now I need to add in tax. Now, how tax is calculated is you take the percent of the tax rate and you multiply it times whatever the price tag is. So I know what the price tag is. It's 0.8x. I need to multiply that times the tax rate to figure out how much Jerome is going to pay in tax. So that is where this equation that was on your answer sheet came from. This is the price tag. 80% of the original is what he's going to pay. The tax is price tag times tax rate. So this whole thing represents tax. So now I just need to solve. Remember your PEMDAS. Multiplication has to come before addition. So if I multiply these two together, I get 0.066x. Now I can add. So that should give you 0.866x equals 2510, and then just divide both sides by 0.866. So x equals $28.98, which is what I had listed, represents the original price of the sweater. So that's 7 and 8. 9 asks how much money he saved, and a lot of people who even got this first one right missed 9 because they weren't thinking real carefully. How much he saved isn't original price minus what he paid. It's original price plus tax. So $28.98 plus the tax that he would pay on that is what he would have paid without the coupon. So that was $31.37. So if you missed 9, it was probably because you forgot to put the tax in. So this is what he would have paid if he didn't have the 20% off, minus what he actually paid. So the savings was $6.27. All right. So moving on, I want to look at one of the absolute values. So let's look at one equation, one or and one and. So number 22, we'll look at A. So that was absolute value of 2x minus 3 equals 7. Remember, if the absolute value term is not alone to begin with, you have to get it alone first before you can do anything else. In this case, it's already alone, so good for us, which means we take away the absolute value bars for the first equation. For the second one, we change the 7 to a -7, and then we solve them each separately. So add 3, 2x equals 10, or add 3 here, 2x equals -4. So I've got x equals 5 or x equals -2. 26 is one where the absolute value term is not alone first. So before you start setting up any sandwiches or ors, you have to get the absolute value term alone. So the first thing I need to do is to add that 9 to both sides and rewrite my result. So absolute value of 10x minus 12 is less than or equal to 8. So now that the term is alone, I can set it up. And since this is a less than, this is a sandwich. So sandwich that 10x minus 12 in between 8 and -8. And now I can solve. So add 12. So 4 less than or equal to 10x less than or equal to 20. Then divide everything by 10. Remember, no decimals. Unless it is real life or there's already a decimal in the original, you should not have a decimal in your answer. Reduce the fraction. It's 2/5. And then 20 divided by 10 obviously comes out. And then because it's a sandwich, when you do the graph, that means you put the two numbers on there and the shading should be between. Since there are equals, that means they're closed in, filled in circles because of the equals, and you've got a graph in the middle. I'm going to do D as well. This was C. So absolute value of x minus 7 plus 3 greater than 8. So again, do not set up a sandwich or an or until you get the absolute value alone. So I've got to subtract the 3 first. So now I've got absolute value of x minus 7 is greater than 5. This is a great or. So it's set up as two separates. One just like the original. The second one, don't forget, you have to flip the symbol and change the sign. So you make it a less than and change it from a 5 to a -5. So now add 7 to both sides. X is greater than 12, or on this side, x is less than 2. Remember that when you graph ors, the shading should go out to the ends. These are open circles this time because there is no equal underneath your inequality symbols. So open circles, shadings to the edges. Remember, if it's a great or, once the absolute values alone, shading should go to the sides. If it's a less than, then the shading should go in the middle. All right, next. I would like to look at, so now we're on the part that's on page 27 and 28, and I would like to look at number 6. All right, so number 6 was the one where you made a table with the temperature in degrees Celsius versus the heat in joules that you would have to apply to change the temperature of the bar. So on this one, I wrote on the answer key that you needed to use the chart. Use the T chart, because if you look just at the function that we wrote in number 5 was this, or some variation of that. If you distributed it, it looked like this. But in number 6, this is an instance where it doesn't make sense to graph this using slope and y-intercept, because this is a real-life situation. We've got heat in joules and we've got temperature in degrees Celsius. So what we're looking at is only going to be the positive temperatures here. So when you graph this, you should just be graphing the T chart. So, and again, I don't have graph paper here, so excuse my sloppy graph. Hopefully yours looks a little bit more. I'm not a huge fan of breaks. I did use one on this one because it jumped, from nothing to 26 and then increased by mostly ones. So I did use a break here, and so I made this my 26 and then counted by 2's, 28, 30, 32, 34, 36, so on and so forth. On the y-axis, I counted by 7's because that was the units we were using. Heat was measured in 7's, so 7, 14, 21, 28, 35, I'm just going to label some as I go, 42, 49, 56, 63, 70, so on and so forth. Don't forget, these need labels. This is temperature in degrees Celsius, and this is heat, and that's measured in joules. So all you're doing here, yes, you have an equation, but we discussed over and over and over again in the lessons that yes, I have a slope and a y-intercept. Yes, it is linear, but it doesn't always make sense to graph it using slope and y-intercept. Here it makes much more sense to plot the points that we know. So 26.7 is a point in the chart, and you can look at number 4 where you've got all of those. 27.14, so here's that point. I don't even have to plot all of them if I don't want. I just need a line. So I could go up to, 30 here, and it says 35. So 30, 35. Okay. I can go up to 35, which was right here, and that was 70. So that's up way at the top of my graph. And you can see here, sorry that I can't connect it in a way that actually makes it look like a line, but that is linear. We know it's linear because we're looking at the equations, which makes this a good time to review. We've talked about this multiple times, and there's a question in the review that has you look, I think it's number 17 in the first section, to determine, and it gives you multiple choice, what's linear and what's not. Remember, if you're asking, is it linear? If you're looking at the graph, that's just the same as asking, is it a line? So it's linear. Sorry, there's not much space between my A and line, but those are two separate words. So if you're looking at the graph, you can tell if it's linear by does it make a line? If yes, it's linear. If no, then it's not. By the equation, we discussed this in class because I wanted to review from Algebra 1. This is a big thing in Algebra 1. If you're looking at the equation, that means that your variable is to the first power, and that also means that it has to be in the numerator. I had some people who came, and asked me questions about things like that wanted to know on that multiple choice, well, why does this make it not linear? Because the x is to the first power. If you think back to Algebra 1, this really is not x to the first power. When that's in the denominator, what that's really like is 4x to the negative first. Hopefully you remember negative exponents because we'll need those later this year. But negative exponents boot things to the denominator. So no, this is not x to the first power at all. So if it's linear, when you're looking at an equation or a function, the variable has to be to the first power and in the numerator. If you're looking at the graph, it's very simple. Is the graph a line? And that's it. All right. Next thing I want to look at are the inequalities. So starting at number 26. So you can write the inequalities, and the key again is separating out the info. If you look at the info that they've given you, you need to separate out what information is only about the black fabric, which information is only about the green, which information is about both. You've got information there that has to do with cost. It says it's $6 per yard for the black, and it's $4 per yard for the green. That's money. We're talking about money. Also related to money, they say total no more than $60. Those all have to be related in an inequality because they're all talking about money. Then it tells you at least 10 yards of fabric overall. So both of these are going to need an x and a y. So it tells you in the problem that you want to let x represent number of yards for the black fabric and y represent the number of yards for the green. So if there's no more than 10 yards overall, or at least, sorry, not no more was on the 60, at least 10 yards, that means yards of black plus yards of green has to be at least, meaning greater than or equal to 10. So that's how I came up with that inequality. This one, if you're buying something that's $6 a yard and you have X yards of it, 6 times X is going to be the cost for the black fabric because you take the cost per yard times how many yards you're buying. Now, total cost isn't just the black fabric, it's also the green. $4 a yard times how many yards? It says no more than, which means less than or equal to 60. So that's where I came up with this one. The other two, it says the designer will need at least 3 yards of black. So black has to be greater than or equal to 3. And then it says at least 4 yards of green. So greater than or equal to 4. And that is where I came up with my inequalities, just from organizing my information and keeping the things that went together. Reasoning, does it need both variables? Does it just need one? Once you have your system, the actual graphing of it, again, if we're graphing this, it doesn't make sense to use all 4 quadrants. It makes sense to use quadrant 1 because we know that x and y can't be negative. In fact, even more than that, we're told that x has to be bigger than 3 and y has to be greater than 4. So Of course, I'm going to label my axes, and you've got your black fabric and green fabric, both measured in yards. So I'm going to count by twos. So 2, 4, 6, 8, 10, 12, 14, 16. There's the halfway part. 2, 4, 6, 8, 10, 12, 14, 16. And now it's just a matter of graphing these. Now these ones, very easy to graph. X greater than or equal to 3. Oops, I hate when I do that. I counted by twos. Ignore that red. I'm going to use a different color now. Even teachers make mistakes, although I normally catch them pretty quickly. Okay, so there's my boundary line, x equals 3. The greater than is going to be everything to the right of that, because all an inequality is shading. That's all a constraint is just shading after you graph the boundary line. Y is greater than or equal to 4. So here's 4 on the Y. There's the boundary line. Greater than or equal. Again, I'm only shading the part that is already shaded, because if not, I don't need it. Okay, now these two. Now, yes, you could most certainly get y by itself and graph it using slope and y-intercept. This one over here, however, if you do that, I'm going to use a different color because it'll stand out more. If you do that, if you go to get the y alone through this process, y less than or equal to negative 3 over 2 x plus 15. So it's got a nice y-intercept, but its slope, when you're counting by twos, might not be the best. So again, t-charts are an option. Remember, finding both intercepts is an option. We did that in one of our lessons. So if I found the x-intercept and the y-intercept here, x-intercept I find by making y 0. So if 6x, and again it's an equals when we're finding an intercept, so the x-intercept here is going to be 10. So here's 10. The y-intercept, so this is the x-intercept, the y-intercept, I make x 0, so 4y equals 60. So the y-intercept is 15. So that's right here. Lo and behold, I've got 2 points. Now, it's very hard for me on this tablet to connect those with a line that does not look curvy. But so much easier than slope and y-intercept, people. So much easier. And it says less than, so that means below. Again, I'm only going to shade in the areas that already had the pink and the blue. So now I've got a little triangle. I've got one more to go. This one, it probably is just as easy to use the slope and y-intercept here. So I would probably have graphed this one that way and this one this way. So y greater than or equal to negative x plus 10. So its y-intercept is 10 right here. A slope of negative 1 means if I'm counting by the same thing on both axes, I can go down 1 unit, right 1 unit. Down 1 unit, right 1 unit, because again, even though I'm counting by twos, I'm counting by twos on both axes, so it still keeps the scale the same. And now it's supposed to be greater than that line. So greater than means above. So now, and again, I gave you an answer key where you can see the area better. Here I'll color it in black, but this is the overlap area for those. Now, some people had asked a question that they didn't quite understand, 29B, which asked you to find the greatest amount of green fabric that the designer can use. So green fabric is this axis. So the greatest amount of green fabric that can be used is the highest, value the top value on the graph, which is right here. That point right there represents the maximum amount of green fabric. So there's two ways that you can tell what that is. And it just depends on how you want to do it. What I did is I said, well, I know that the X value here for that green fabric is 3. And I know that this line is my green one here. So I just plugged 3 into this equation. So this was 29b. So I took x equals 3 and I put it in, and I essentially solved for y. So subtract that on both sides, and you should get, let's see, minus 20 would be 40, so it's 42. And so then your y is 10.5. So that's how I came up with that. A couple people had asked about where you got that. Now, if you used graph paper to make your actual graph, and you could actually see that exact value exactly, and you knew you weren't estimating, that would be totally fine. My graph here is even off because of the fact that it's not on graph paper. It's not perfectly scaled. I can't draw lines that don't look like curves with this pen. So if you used graph paper and you just said, I went to the highest, y value, it was 10.5, that is a perfectly acceptable answer. Perfectly acceptable. All right, I also want to quickly revisit something on your 2x2s and 3x3s. So the substitution, I'm going to look at substitution on the 2x2. So we're look at number 5, which was 5y minus x equals negative 5. 7y minus x equals negative 23. So to solve this by substitution, first we need to get a variable alone. Don't choose one of the y's. They don't have a coefficient of 1 or negative 1. Choose one of the x's. It doesn't matter which one you choose. I chose the top one. So if I'm going to get x alone, that means I need to subtract the 5y on both sides. So negative x equals negative 5 minus 5y. Then I need to divide by negative 1, and x equals 5 plus 5y. Once you have that value for x, take x out of the other equation. Everything else about the other equation is the same, and substitute this value in, so 5 plus 5y. Now, don't forget, this is a negative. It means distributed, so 7y minus 5y equals negative 23. So combine these like terms, 2y minus 5 equals negative 23. Add the 5 on both sides, and 2y equals negative 18, which is how I got y equals negative 9. Once I know that, I plugged it in back up here. So this is negative 45 plus 5 is negative 40. So that means my ordered pair, negative 40, negative 9. Do not forget to review in your book. It's on number 5, but the consistent and dependent, consistent, independent, I'm not going to go through all of that again. But if you want to look back at where that is in your actual lessons that we went through and worked through, that would be in section 3.1. So it was on page 30. So if you don't know the consistent, inconsistent, dependent, independent, and what those mean, I would look back at those on page 30. All right. Last one, I want to pick one of the 3x3s just to review one more time. So I'm going to do number 9. Since I already did substitution on the 2x2, I'm going to do elimination on the 3x3. So number 9, 2x plus 4y plus c equals 31. Negative 2x plus 2y minus 3z equals negative 9. X plus 3y plus 2z equals 21. All right, so when you're doing elimination, remember your first step is to pick a pair of equations. So I first am going to pick equation 1 and equation 2 because the first thing that caught my eye was these are already opposites. So I'm going to choose equation 1 and equation 2. I always recopy them just so I have them written right underneath each other with no other equations kind of messing up your line of sight. So since they're already opposites, I don't have to multiply anything. I can go ahead and add straight down. So the x's cancel out. I get 6y. Here I get negative 2z. And here I get 22. So there's my new equation 1. Now I need to pick a different pair. So I strategized and I used 2 and 3. Because 2 was already negative, meaning that I could multiply by something positive here. Certainly you can choose 1 and 3 also. That is not wrong. So I chose 2 and 3. And in order to get opposites on those x's, because we have to get opposites on the same variable, I have to multiply equation 3 by 2. So I'm going to copy equation 2 just as it was. So negative 2x plus 2y minus 3z equals negative 9. And I'm going to multiply equation 3 by 2. So 2 times x is 2x. 2 times 3y is 6y. 2 times 2z is 4z. 2 times 21 is 42. So now I'm going to go ahead and add straight down in my columns. So x's cancel. I've got 8y plus z equals 33. So again, once you've picked those two pairs and you have eliminated one of your variables, now it's back to an Algebra 1 question. It's just a 2 by 2. So take these two, and I need to solve that system. So 6 and 8 don't look great to get opposites, but these z's look good to get opposites. If this is negative 2, I can make this positive 2 by simply multiplying by 2. So that gives me 16y plus 2z equals 66. And now I would either suggest recopying this or just like drawing a line through it so you don't accidentally add that one with this one. So now add 6y and 16y gives me 22y. The z's drop out. This gives me 88. So divide by 22 and y is 4. Yay! I know what y is, so that means I can find z. So I'm going to plug it back in. Doesn't matter which one of these you plug it into. I'll just do this one since it's already on the bottom. But 8 times 4 plus z equals 33. 8 times 4 is 32. So subtract the 32 from both sides. Z is 1. So I've got z is 1, y is 4. Now work my way back up to the original so that I can plug both of those values in. I chose the last equation. So right here I did x plus 3 times y, which was 4, plus 2 times z, which is 1. I kind of ran out of room there, equals 21. So 3 times 4 is 12. So x plus 12 plus 2 times 1 is 2 equals 21. So x plus 14 equals 21, which means that x is 7. So ordered triple would be 7, 4, 1. And there is your answer. So we've gone through, we've reviewed how to graph something using intercepts, how to graph something using a table, using your t-chart. We've reviewed how to graph something using the slope and y-intercept, which was this one. We've talked about what makes equations linear. We've reviewed these absolute values, writing equations, writing inequalities. So that hits all of the major topics that are going to be on the skills portion of Monday's quiz. So I'll be here before school on Monday if for some reason you have last minute questions other than the ones that I went over. Otherwise, I will see you then. Have a good night.